thank you for joining us to learn about how to conduct pathogens monitoring using Environmental Protection Agency equipment and protocol. Groups around the New York, New Jersey harbor estuary conduct water quality sampling during the summer to identify times when using our waterways for recreation might pose health risk. The samples are analyzed by the Interstate Environmental Commission, and the results of the water test are shared with the public so that they can make informed decisions about whether it is safe to fish, paddle, or swim in local waters. Many groups also analyze water quality data in relation to other data like rainfall, temperature, and tides to better understand the role that the environmental and other factors play in the presence of disease-causing pathogens in our waters. Volunteer water quality monitors like you play an important role in helping us learn about the health and safety of our waters. This training video will guide you through the steps required to ensure proper calibration of the equipment we use, to ensure that the data we collect is of high quality and our methods are consistent from week to week to allow for analysis. Today, we are going to introduce you to a piece of equipment called a YSI Pro DSS, which is a multi-parameter digital water sampling instrument we use to test water quality. In this video, we will learn how to calibrate the YSI Pro DSS using chemicals called standards. The YSI Pro DSS is a device fitted with different sensors. We use the terms probes and sensors interchangeably. Each sensor gathers a different type of data or parameter about the water we test. The YSI stores the data about salinity, conductivity, pH, and other information relayed by the sensors. The YSI also collects information about the water, like temperature and latitude and longitude. We collect this information at each of our sampling sites for each monitoring day, and at the end of the day, we download the data from the YSI into spreadsheets for analysis. Before every sampling session, we have to first calibrate the YSI to ensure that the measurements it takes are consistent with universal standards. This is important for quality assurance, ensures consistency in sampling methods over time and in different conditions, and is what allows us to understand differences in data gathered across sites. First, let's meet the YSI. This piece of equipment has four main parts: the handheld, the cable, the calibration cup and retaining nut, and the sensors. The handheld has a screen and a portal for data download. The long cable is what allows partner work, with one partner in the water with the sonde and the other on land reading the data. The calibration cup and retaining nut are used for calibration and for protecting the sensors. The YSI has 4 ports to connect the sensors, which are very delicate and are protected by an additional sensor guard. Here's a sneak peek at what the sensors look like before they are placed inside the sensor guard. To calibrate the YSI, you will need the following tools and equipment: YSI fitted with the appropriate sensors, calibration standards or buffers, these terms are used interchangeably, clean water, calibration sheet, a pen or permanent marker. Pre-calibration instructions. Before you begin, you should turn on the YSI at least 5 to 10 minutes ahead of time to allow the sensors to warm up. While the equipment is warming up, you can begin preparing other materials for your sampling day, including your calibration sheets, fresh water, and buffers. Calibration can be done in any order as long as conductivity salinity is calibrated before dissolved oxygen. First, we will calibrate for pH. pH is the measure of how acidic or basic water is. Technically, it is the measure of availability of hydrogen ions, with more free hydrogen ions creating acidic conditions. The pH of water is related to the amount of chemicals that can be dissolved in water and how available dissolved chemicals are for biological activity. pH results exceeding 8.0 or less than 6.0 are of concern. We have to use 3 different standards to calibrate for pH in 3 different conditions: acidic, basic, and neutral. We begin pH calibration using the red buffer for pH 4 to calibrate for acidic conditions. To start, fill the calibration cup to the first line. We then insert the sonde. On the YSI, press the Cal button and select pH. Once the white line on the graph stabilizes, use the numbers under actual readings to fill out pre-calibration pH and buffer temp on the calibration sheet. Use the number under post-cal value for post-calibration pH. At this point, it should say ready for cal point 1 at the bottom of the screen. Select Accept Calibration and wait for the message Calibrating Sensor to pop up. Now, it should say ready for cal point 2 at the bottom of the screen, meaning you can move on to your next buffer. Be careful not to press the Accept option more than once, or it will move on to the cal point 3 and you will have to discard and redo the calibration. Now, you can calibrate for pH 10.00 or basic conditions using the blue buffer. Begin by discarding the red buffer we used for pH 4.00. Then rinse the calibration cup and sensors with fresh water. Once you're ready, use the pH 10.00 buffer to fill the calibration cup to the first line and insert the sonde. Once the white line is stabilized, record the temperature along with the pre- and post-calibration readings on the calibration sheet. Then, go ahead and select Accept Calibration on the YSI. Once it says Ready for cal point 3, select Finish Calibration. The handheld should return to the calibration menu with the message Calibration Successful at the bottom of the screen. Now we will move on to the yellow buffer for pH 7.00 to mimic neutral conditions. At this point, you can click the Escape button to get back to the home screen. Discard the blue buffer that was used, and then rinse the calibration cup and its sensors. Proceed to fill the cup up to the first line with the pH 7.00 buffer and then insert the sonde. On the screen, the pH value must read within 6.90 and 7.10. Record the value and temperature under post-calibration pH on the calibration sheet, and then discard the buffer. If the reading is not within the accepted range, you will need to recalibrate. If recalibration is necessary, be sure you also record the time it was performed. Conductivity salinity. Great job! Our next step in the calibration process is conductivity salinity. Salinity refers to the concentration of dissolved salts, such as sodium chloride. Fresh water has less than 1 part per thousand concentration of salts. Ocean water has over 35 parts per thousand of salt. Dissolved salts can impede biological activity in freshwater organisms. Since the waters of the New York, New Jersey harbor estuary are tidally influenced, we do expect higher salinity readings that vary with the tides. However, saline water can also be the result of industrial discharges or road salts. Always make sure you rinse the sensors and calibration cup after using any buffers. After rinsing, tilt the calibration cup at an angle and slowly pour the conductivity standard up to the second line to prevent bubbles. Then insert the sonde slowly at an angle. Gently rotate or move the sensors up and down to remove any air bubbles that may be trapped in the conductivity cell. When ready, press the cal button, select conductivity, and then specific conductance. Next, you will need to change the calibration value to 50,000 microsiemens. Allow the sensor to sit for at least 40 seconds for temperature equilibration, and then use the value under actual readings to record the pre-calibration concentration on the calibration sheet. After you're done, select Accept Calibration, and the message at the bottom of the screen should read Calibrating Sensor. Once complete, the message Calibration Successful will be displayed again and the screen will return to the calibration menu. Press Escape to return to the home page to read temperature and the SPC value and record it on the calibration sheet under post-calibration concentration.
The post-cal value must read between 49,500 to 50,500.
If the reading is not within this range, you will need to discard the calibrant, rinse the sensors, and recalibrate. Dissolved oxygen. Halfway done. Next up is dissolved oxygen. Fast-moving water in rivers and streams usually has higher dissolved oxygen than slowly moving water. However, certain pollutants in the water, especially nutrients like phosphorus, nitrogen, and fecal waste, increase anaerobic processes and can decrease the amount of oxygen. When water moves slowly, bacteria and other organisms in the water can use the dissolved oxygen to a point where there is not enough dissolved oxygen to support life. As the amount of oxygen approaches zero, anaerobic processes take over. As always, discard the buffer from the calibration cup and then rinse it along with the sensors. Fill the calibration cup up with about half an inch of fresh water, insert the sonde, and partially tighten the retaining nut to allow airflow. Wait for 5 to 15 minutes while the air becomes saturated with water. Then, press the cal button and select ODO/DO. Select DO percentage and wait for the numbers to stabilize. Use the numbers under actual readings to fill out pre-calibration percent saturation on the calibration sheet. SAT is short for saturation. You will also need to record the barometric pressure and temperature. Select Accept Calibration, and once it's complete, it will return to the calibration menu and display the message, Calibration Successful. Escape to the home screen and fill out the values for post-calibration DO percentage and post-calibration mg/L on the calibration sheet. The post-calibration value for percent saturation should be between 97 and 103%. Record the time and if recalibration was performed. Moving on, now we're preparing the equipment to measure chlorophyll. Chlorophyll is the name of the green pigment that plants use to make food during photosynthesis. Measuring chlorophyll can help identify algal bloom events and their effects on water quality. Once again, rinse the calibration cup and sensors with fresh water. Using deionized water, fill the calibration cup to the first line and then insert the sonde. Press the Cal button and then click on TALP, seen on the screen as TAL-PE. TALP stands for Total Algae Phytoerythrin. Select chloro UG/L and then give the numbers a few seconds to stabilize. Use the value and temperature under actual readings and record them on the calibration sheet under pre-calibration 0 value UG/L. Select Accept Calibration and wait for the screen to return to the calibration menu with the calibration successful message displayed. Escape to the home screen and record chlorophyll UG/L and temperature readings on the screen to fill out post-calibration 0 value UG/L on the calibration sheet. Now, the last and most important step is to repeat the calibration for chloro-RFU. Chloro-RFU stands for Relative Fluorescence Units. It needs to be calibrated twice, and the post-cal values should be between -0.3 and 0.3 for both units. Once you're done, record the time and if any recalibration was done. That's it. Now you're ready for monitoring.